Hi, this is Mrs. Rodriguez, your algebra teacher. This video is about lesson 9-6 in the textbook, and it is titled Analyzing Functions with Successive Differences. Okay, so let's go ahead and jump right into the lesson here. All right, so first thing, we need to be able to identify functions, okay? So you can use linear functions, quadratic functions, and exponential functions to model data. The general forms of the equations and a graph of each function type are listed below. So here we should know by now what a linear function looks like. It's a line. Okay? Quadratic function is going to be a parabola, and it's in this format: y equals ax squared plus bx plus c. So right away, by looking at an equation, we should be able to tell, or at least have a sense of what the graph is going to look like. Over here for linear functions, the format is y equals mx plus b. Remember that slope-intercept form. And then exponential functions are in the format y equals ab to the power of x. So remember, the variable is in the exponent, okay? And then it's this shape here, like in asymptote, okay? All right, so another way to determine which model best describes data is to use patterns. Okay, so the differences of successive y values are called first differences, and the differences of successive first differences are called second differences. Okay, so if the differences of successive y values are all equal, okay, meaning whatever data you're given, you look at the y values and each one has have equal differences, okay? So the change in y is the same, okay, from one point to the next point. Then the data represents a linear function. Okay, that's going to be a line. If the second differences are all equal, but the first differences are not equal, then we have a quadratic function. Okay, and then if the ratios of successive y values are all equal and r is not equal to 1, the data represents an exponential function. Okay. All right, so if we look at this table here, remember we're looking at the y values, okay? We want to find the difference from one value to the next. And notice each one of these in the x, they're going up by 1, okay? They're going up by 1 value. So these are consecutive points, okay? So then here we've got -3, to what happens from -3 to -7? Well, you subtract 4, okay? And then when you go from -7 to -9, you subtract 2. When you go to -9 to -9, well, you subtract 0. And then if you go from -9 to -7, then you have added 2, okay? So here we're going to end up with a quadratic, okay? Quadratic, because the differences are not the same, okay? They are not the same. The first difference, the second differences are all equal, but the first differences are not equal, okay? All right, and then here, again, we have consecutive values here, okay, and our x. Then we're looking at the y values. Now to go from -18 to -13, you would add 5. And then -13 to -8, again, you would add 5. -8 to -3, again, you would add 5. And -3 to +2, again, you would add 5. So this would be an example of a linear function, okay? Next couple of examples say, determine which kind of model best describes the data, which is what we're just doing, and then write an equation for the function that models the data, okay? So here, once again, if we look at our x values, they're all going up by 1. So if we look at the y value, to go from 11 to 7, we are subtracting 4. 7 to 3, again, subtracting 4. 3 to -1, again, subtracting 4. and -1 to -5, again subtracting 4. So all of the differences are equal to each other, so this is going to be linear, okay? So remember the linear format, we would use the slope-intercept form, y equals mx plus b, okay? And we know that the slope, or m, is going to be -4, because remember that's a change in y, -4x, and then plus b, which is the y-intercept, okay? So y-intercept is going to be +3, okay? And we get that from the graph there, okay? All right. So here we have another function. Okay, we can see the values are going up by 1. So we're going to look at the differences in the y values. Okay, so if we look, how do we get from 375 thousandths to 7,500ths? Well, what's happening is we multiplied by 2. And 7,500ths to 1.5, again, we multiplied by 2. And then 1.5 to 3, again, we multiplied by 2. And then 3 to 6, again, we multiplied by 2. Okay, so this is going to be an exponential function. Okay, and remember the standard form would be y equals a times b times x. Okay, and so we would have y equals, we don't know a, but b is the constant ratio, okay? The constant ratio is multiplying by 2, okay? And we're raising that to the power of x, okay? So what we can do is try to solve for a. So if I plug in 0 for x, okay, then I should get 3 as my y value into this equation here. So if I have 3 equals a to the power times 2 to the power of 0, I should get 3. Okay, and the reason I picked the 2 to the power of 0 because I know 2 to the power of 0 is equal to 1, right? So anything to the power of 0 is equal to 1. So 3 is equal to a times 1, which is a, and that helps me figure out the value of a. So now I know a is equal to 3, and then my constant ratio is 2, and I'm raising it to the power of x. So that would be my equation. Okay. All right, so that's all for this lesson. Hopefully this is a little bit clearer now. If you have any questions, please call, text, email, or stop by my office hours, and I would be happy to help you. Okay? You have a great day.